So Patricia, Professor in the Department of Engineering and the Universidad Nacional de La Plata, we have good collaboration with them. And we asked her to give a talk changing a little bit on related to energy. Thank you, Patricia.
Okay, I share my presentation. My theme is about energy transition and the role of electrical energy. When we talk about the energy matrix, we refer to the combination of primary energy sources in a geographical area, which can be a country or maybe the world. Electrical energy is a secondary source of energy, which we obtain from primary sources. It is an energy vector, and we use it to transport and distribute energy in the amount required by the user to transform it back into another form of energy. Taking the current Sankey diagram as a reference published on the page of the International Energy Agency, we can see the primary resource, the different forms of transform the energy like refineries or power station, and the final consumption like industry, transport, other, here are commerce, public, and service public, and non-energy use. For the year 2020, the primary resource was 19,530 million tons of equivalent oil equivalent, and the final consumption was 9,571. For this resource, we have for electrical energy 545,445 million tons of oil equivalent. It means only 28% of the total resource. It is clearly observed that the electrical energy matrix is only a part of the energy matrix of the world or even of the country. The situation was similar to in 1973, and the numbers are very lower. We observe that with the passing of the years, you use a greater quantity of primary resources for the generation of electricity. On the other hand, we can observe how consumption in industry, transport, and other, here residence, commerce, and public services, agriculture, and forestry. And we can see in light blue the percentage of electrical energy, which has clearly increased in this period. In this table, we compare the difference of production, final consumption, and power electricity, and the relation is the two for production and final consumption, but for power electricity is almost 4. And the way of the different consumption, we can see that for other residential and commerce, we have the electricity like almost 6, the relation between 2020 and 73. Regarding the growth in electricity generation has been very uneven for some countries. We observe the significant growth of Asia Pacific, which include China and India, while South and Central America do not represent the same behavior. Regarding the resources used in generation of electrical energy, it's observed that in the period 1985 to 2021, the electrical matrix worldwide has been very different from of South and Central America. Globally, coal continues with a participation of 35 or 40%, while South and Central America is only 5%. And here, the clean energy is 67%. 67%. Looking at the map, we can see the difference of total electricity generation for different countries during 1903, excuse me, during 1903, excuse me, and 2020. And we can see the emissions of CO2 in the same period, yes? We observed during the last years the difference of the emissions of different countries, and we can observe the big increase of People's Republic of China. We didn't have any data about Russian Federation. The first data is for 1990. And in green, light green, we can see the emission of Argentina. The countries have committed themselves to achieve objectives of common interest. The 2030 Agenda for Sustainable Development, a pioneering committee on a global scale. It proposed to eliminate poverty and lead the world to a sustainable path towards inclusive development. 17 Sustainable Development Goals and 169 action targets. They are universally applicable regardless of the level of the development of the respective countries. It is an inclusive agenda. They address the root causes of poverty and unite us to achieve positive change for the benefit of people and the planet. At the same time, climate change imposes another agenda. In order not to exceed an increase in global temperature of 1.5 degrees Celsius, it is necessary to reduce emissions by 45% by 2030 and net zero by 2050. The International Energy Agency has pointed out that the world has a viable path to build a global energy sector with net zero 2050. And it requires an unprecedented transformation of how it is produced, transported, and used energy around the world. Therefore, there will be no human activity that can avoid participating to a greater or lesser extent in the energy transition that humanity must carry out. In this roadmap for the global energy sector, we can see the electricity becomes the core of the energy system. It will play a key role in all sectors, from transport and buildings to industry. Electricity generation must achieve net zero emissions. 50% of the total energy consumed in 2050 will be electric. New low-emission industries are flourishing. Electric mobility, airplanes will rely on advanced biofuels and synthetic fuels, and hundreds of industrial plants will have to contemplate carbon capture or hydrogen use around the world. Nearly 90% of global electricity generation by 2050 will from clean sources, and solar PV and wind together will account for nearly 70%. Hydrogen and nuclear will cover the rest. Efficient solutions for buildings, vehicles, appliances, and industry are available today and can be scaled up quickly, creating many jobs in the process. That is the situation actually where the main resources are coal, natural gas, and oil that we use directly in industry, transport, buildings, and other. And some part of them are transformed by electricity with modern bioenergy, other renewables, and nuclear. The situation at the future is coal, natural gas, and oil reduce significantly, and then we must increase the modern bioenergy, other renewables, and nuclear to transform in electricity, and the electricity is the main source for industry, transport, buildings, and others. The emissions total for sectors is necessary to reduce with different efforts. Power section have to 2040 to 2050 negative numbers. It means it's necessary to capture CO2 in these sectors. One way to capture CO2 is together the natural solution is possible to capture CO2. Arnera points out of the key of reduction almost 37 gigaton CO2 of annual CO2 emissions by 2050. It can be achieved by contemplating significant increase in the generation and direct use of electricity based in renewable energy, substantial improvements in energy efficiency, electrification and end-use sectors in electric vehicles and heat pumps, clean hydrogen and its derivatives, biological bioenergy coupled with carbon capture and storage, and use of last mile carbon capture and storage. The Energy Committee of the International Council of Academies of Engineering and Technological Sciences, GAES, has been taken with reviewing existing technologies which can be used to reduce the CO2 emissions. The 7 key sectors was food and agriculture, buildings and smart cities, oil and gas, chemicals, cement, iron and steel, information and communication technologies. This sector in 2019, these 7 sectors selected accounting for 73% of industry CO2 emission and around 60% of worldwide methane emissions. The report shows reducing CO2 is in many cases achieved through the electrification of all or part of the energy used, whether for home heating and cooking or for industrial processes. Low carbon electricity, less than 50 grams per kilowatt hour, is therefore mainly produced by hydro, solar, wind, and nuclear power. Some industrial processes cannot be fully electrified, like cement. Then hydrogen, if it is produced with low carbon electricity, may be part of the solution. Main remarks. Energy is the key to the social and economic development of society. Energy transition is a set of changes in energy production, distribution, and consumption models to avoid greenhouse gas emissions. The situation of each country can be very different, but we must all make the effort. Energy transition is not only renewable resources, it is also avoid waste and improve global efficiency, mainly in the final stage of demand. Transform final consumption into electricity, build reliable and resilient infrastructure like transmission and distribution, promote clean energy, and include carbon sequestration strategies. Electrical energy is the key to the energy transition.
Gracias, Patricia.
Okay, thank you.